Hello again. So we've seen how to apply the idea of CNNs to images, and again, try it out. We're probably not going to do this in the lab because we're going to focus on text processing, but it's a fun experiment. And yeah, really not that complicated to set up. But here we have been interested a lot in text processing, for example, for the chatbot. So can we apply this idea of a deep CNN network for text processing as well? Obviously, in a text, we don't have a 2D information like in an image. So we can't really have these 2D filters. But what we do have in the text is basically a one-dimensional filter because a text has a linear information. So remember, we don't want to use a bag of words model where we just take all the words, no matter where they appear. We want to sort of keep track of the sequence of words. So what we have, instead of two-dimensional convolutions, we can apply one-dimensional convolutions. So for example, we could apply a 1 times 3 filter, 1 dimension times 3. So basically 3 words. And then we move this filter across the text. Now, the filter was the mathematical operation that we've seen earlier. So how can we apply this to the words that we have? And last time you've seen how we can do this, how we can represent a text in form of numbers, namely the word embeddings that we calculated last time. So here we have an example input sentence. The cat and dog went to the bodega together. If you don't know what a bodega is, we call it differently in Montreal. This is the New York City edition. So if you're not sure, look it up. So what we do is, last time we learned how we can represent each word as a vector. So here it's just shown as 6-dimensional vectors, but remember, the typical word embeddings have a few hundred dimensions. So each word becomes one vector. And now we can apply, first we can encode our input text in form of embeddings, in form of word vectors. And then we can apply these filters on the input word vectors. So for example, we have a 3-dimensional filter here. We are sliding this filter across the text. So this is our convolution operation. And then we are applying this filter on the input text, and then we get, for a given filter, an output sequence, an output layer that we can then process further. So there is another kind of layer in deep networks that I haven't showed you yet, and that's the so-called pooling layer. Pooling layer is basically a kind of compressing or summarization layer. So basically we are generating a smaller representation from a bigger one. And there are 2 ways of doing it. One is doing kind of an average operation, and the other is a maximum operation. In this case here, we are back to an image. So we want to do a 2D pooling operation, and the one we are using is the max pooling operation, meaning we take these 2x2 windows, we apply it over our 4x4 input image, and then in each 2x2 window, we are looking for the maximum element. So in here, the maximum is 0.33, so we get 0.33 here. And this 2x2 window, the maximum is 0.66. And so on. So we get a 2x2 output using the max operation. And the second way of doing it is doing an average. So you could take all the values here, compute the average, and then you would put the average result in here. For text, again, we are applying this not in 2 dimensions, but in 1 dimensions. So for example, we could do a 1 times 2 window. So for the first 2 words, we would take the maximum here. The second 2 words, again, the maximum. third two bits, and the last two. And we get this resulting output vector. We can also do a 1D global max pooling, meaning we look at the maximum element in the whole vector. And for this vector here, the output would be 0.99. So pooling gives us a way to do dimensionality reduction in our data. So we have some input data, and then the output is a filtered, a reduced version of each data sample. So essentially, we are throwing away a bit of data by reducing the size, by compressing it. And the way we're compressing is choosing a representative in a given window. And two ways of doing it typically is maximum and average. So for images, it's a 2x2 window, but for text, it's a one-dimensional window. For example, 1x2 or 1x3. So to make sure you understand how the pooling operation works, there is an exercise, task number 3, applying it on an image. And then when you're back, we're going to build a network for processing text using all of these techniques together. See you then.